Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 6. We are over the halfway point. Question 6 on our 2009 Euclid contest. So we've got an A part and a B part as standard in the middle of the contest. A part, an integer n with, so n is a 3-digit integer. So it's between 100 and 99 inclusive. It's chosen at random. What is the probability that the sum of the digits of n is 24? So we need exactly 24. Okay, so chosen at random, probability, we're going to need to do two sort of counting calculations. We're going to need to figure out, one, how many of these 3-digit numbers actually have a sum that is 24. And we're going to need to place that in the numerator, and then in the denominator, we're going to need to figure out just the total number of 3-digit numbers that could have been picked, period. Okay, this is how probability works when you don't have any sort of weighting or anything like that, which is nothing we need to worry about. Okay, so, you got to do two counting arguments. One will be a little harder than the other. Now, the thing that strikes me is 24 is actually pretty high. The most that a 3-digit number can have its digits add up to is if you add 999, and that's 27. It's only 3 more than the 24 we seek, so I don't imagine that there are going to be that many. Some, certainly, but I'd be guessing, 30-ish maybe, but that's just random guess in my head. Let's actually figure out how many we would have. Okay, so probability is going to be a number of n with a sum of 24 divided by the number of possible values to pick. Okay, so the number of possible values to pick is probably the easiest one to figure out. Usually the denominator is the easier one. If not, then it's no harder than the top one, certainly. So we can go from 100 to 99 inclusive. How do we figure out how many numbers are inclusive? Take 99 minus 100, add on 1. Okay, and this turns out to be 900. So how does this work? Well, if I have something like A plus 1, A plus 2, all the way up to B, so I'm including my A and my B, how many numbers are between A and B? Or how many numbers do I have to go through to get from A to B? Well, I go 1, 2, all the way up to B, but B is A plus B minus A, which is kind of a silly way to write it out, but we'd have 1, 2, 3, 4, all the way up to, and then we've got B minus A. So there's B minus A numbers here, and then we just add on one more for the A that we have left off, that we haven't counted yet. So that's why this formula works. Okay, so we've got 900, so this is going to be something over 900, and now the real challenge begins, and I think I'll get a fresh sheet of paper here. Okay, so 24. So we could have 999. So in the absence of trying to of knowing a particular patterny way to write this out, I'm just gonna play around until I get one that actually works. So if I had 999, the sum would be 27. So I suppose I could have something like 996. Okay. And that could work, and then, well, once I have that sum, I can borrow from some of the 9s and add on to this 6. So, knowing that there are some that'll work, what's the best way to write this out? So the n with a digital sum tends to be what it's called. N with a sum of 24. If we have, well, 3 9s is impossible, but we could have 2 9s. We have 9, 9, must have a 6. Okay, and this gives us 3 numbers, 996, 969, and 699. So that's 3 possible n. Now, if I just have 1 9, well, we have a lot of possibilities. What if we have just 1 8 as well? So I'd have 9, 8. I'm just decreasing sort of my next digit. So I could say, let n be a, b, c with a bigger than b, bigger than c, or something like that. Bigger than or equal. And that's sort of what I'm doing. I'm taking the biggest I could have, 2 9s, then I'm going to have a 6. Then the next biggest I could have is a 9 and an 8, because that adds up to 17. And that would mean I have to have a 7, and this is going to give us 6 different n. Why 6? Well, I've got 3 different numbers, and the number of possible ways to rearrange them is 3 factorial, or 3 times 2 times 1. So that's how I'm able to do that in my head so fast. But I'll write them all out. So there's all 6 that you get with a 9, an 8, and a 7. Okay, what if we have... what's the next biggest sum? So, a 9 and an 8. I could have a 9 and a 7. That adds up to 16. There is another way to get 16, and that would be 2 8s. We'll deal with that in a moment. So I have a 9 and a 7. That adds up to 16. I would need an 8. Well, I already did that. So that's nothing new. Okay. I could either count that as a separate case, and then I wouldn't have this 9 7 right here. Or I could say, no, I've already got that set of numbers. So what else could I have? I could have a 3 8s. So if we have 2 8s, I'll have an 8, and 8 plus 8 is 16, plus another 8 is the 24 I seek. And this just gives me one n value, that's 8, 8, 8. Could I have anything less? Could I have a sum that goes up to 15? Well, if A and B add up to 15, you'll get A, B, and the thing that remains must be a 9. But we've already dealt with all the situations that have 9s, so we don't have to worry about this. So the number of n values, if I'm not mistaken, is 3 plus 6 plus 1, or 10. So the probability is going to be 10 out of 900, which I guess we can be nice and simplify and say it's 1 out of 90. Okay. So that's, what is it, 6A. Okay, and what have we got for 6B, which we have to write up? Alice drove from town E to town F at a constant speed of 60 kilometers per hour. Bob drove from F to E along the same road, also at a constant speed, although they don't tell me his speed. They started their journeys at the same time and passed each other at point G. Okay. Alice drove from G to F in 45 minutes, and I know how fast she drives, so I could figure out G to F. Bob drove from G to E in 20 minutes. I don't know how fast his speed is. Oh, we're being asked to determine Bob's constant speed. Okay. What could we do? Well, I could give Bob's speed a name, like, let B equals Bob's speed. So I'll set up some equations, hopefully, in terms of B, and then, well, we'll solve for B, I hope. Okay. So they reach G at the same time. Now, there's not a whole lot I know, but distance GF. So I think the key to this question is understanding the relationship between distance, speed, and time. This is a triangle I've drawn in a couple of videos. But basically, if I want to know, so we've got D for distance, S for speed, T for time. If I want to know, for example, speed, I calculate it by doing distance over time. Or if I want to know distance, like the distance GF, I get rid of the D, and now it's just S times T written together. So I know that this is Alice's speed times the time it takes her, and we know that that's 45 minutes. I'm going to turn this into 3/4 of an hour. 60 over 4 is 15, times 3 is 45, so we'll get 45 kilometers. Okay, so GF is 45 kilometers. Okay. And I don't know a whole lot more. I do know it takes them the same time to reach point G. I don't know how far or how long EG is. So EG should be Bob's speed times time. So that's B kilometers per hour times 20 minutes, but I can change that into 1/3 of an hour. Yeah, 20 minutes over 60 minutes. Yeah, 1/3 of an hour. Okay. Oops, it's not 60. Let's not make that fatal mistake. B, so EG is B over 3 kilometers. Okay. Now, I still don't have an equation involving something equals B, but I think that's about to change. So I know the length EG, and I know Alice's speed. So I can figure out, in terms of B, how long it takes her to go from E to G. I know the length of GF. I know Bob's speed in terms of B. So I should be able to figure out the time it takes Bob to go from F to G, and those are the same time. So we might say something like time Alice to go from E to G. I'd probably write a full sentence. Time Alice E to G equals 1/3 B kilometers over 60 kilometers per hour. And so that's going to be 1 over 180, or B over 180 hours. Okay, B over 180 hours. All right, the time for Bob to go from F to G is 45 kilometers over B kilometers per hour, and that's just, I guess, 45 over B hours. So I'd say since they reach G at same time and left at the same time, we can see B over 180 has got to be the same as 45 over B. So multiply both sides by B, multiply both sides by 180, we'll get 45 times 180. 180 degrees is 2 right angles, and each of those is 2 45-degree angles, so this is 45 times 4 times 45. Better known, I guess, as 90 squared, so B has to be 90. Alright. You can get your calculator and double check that if you want to, but yeah, because that's 2 2s. 245 and a 245. Yeah, that's 90. 90 squared, yeah. So Bob travels at 90 kilometers per hour. And if we want to, we could double check some things like how far really is it from E to G. It would be 30 kilometers. And, so 30 and 45. Bob definitely should be moving faster if he's covering that distance. And they both take half an hour to reach G. Interesting things like that. Irrelevant things, because all we care about is Bob's constant speed. We'll just double check. Yeah, that is what they asked for. Okay, so that's it for question number 6. I guess up next will be question number 7. The B part looks like it has maybe a parabola in it, but we will figure that out in the next video. I'll see you there.